Then come resistors. Resistors control the flow of current and voltage and manage this control for each of the different applications on the board. This idea of resistors is very easily shown by the concept or the function of a traffic roundabout. Now, this area behind me was previously controlled by stop signs. This absolutely stopped the flow of traffic because you had to bring your car to a stop, and it limited the flow around it to one car at a time. By installing a roundabout, you can keep the speed, although smaller, and manage the flow. So you're having cars continually move. This is exactly how resistors behave. They control the flow of current and at what voltage within a complex circuit. This idea of current and voltage management is produced by the orientation of resistors as either being in parallel or in series. I'd like to introduce you to a couple pieces of equipment before we actually get to working with circuits, which is our lesson and focus of our lesson next time. Well, let's look at and put up our two expressions again just real quick here. We've been talking about series resistors, and in series, the equivalent resistor is the sum of the equivalent, or the sum of the individual resistors. In parallel, the equivalent resistance is the inverse of the sum of the inverses. So this is how you determine the equivalent resistors or resistance for resistors in series and resistors in parallel. All right. One more thing here. Well, let's go straight to it. If we're looking at a resistor, now this device right here, and you've seen it a couple times, but I never really spoke of it. This device is called a multimeter, a multimeter, a number of different ways. But it is a meter that measured, and this is a digital meter, that takes several different readings. For example, I have it set to measure resistance. I have it set to measure ohms. However, this meter can also measure voltage, both DC voltage and AC voltage. Now we're going to be working with DC voltage, and so we will be using this button right here, or this dial setting, to measure resistance. We'll be using this dial setting to measure DC voltage, and we will also be using this dial setting right over here to measure current. This meter measures a lot of different things, and whatever you want to measure, you use these two probes. Well, you can measure voltage across an element. Remember, it's just considering the difference between one end and the other, and the voltage doesn't have to flow through the device. Same thing with resistance. There's a battery inside here that if you touch the two probes to any conductor, it will measure the resistance by pushing a small current through that object and measure it. Now when measuring current, if you want to measure current, it has to be, the meter, these probes have to be part of the circuit. So you have to make or disconnect a part of the circuit and plug these two things into that circuit. So this is the device that we're going to be using in our work with simple circuits. To measure resistance, you can take a simple resistor and put it between the two probes. If you do, you can see on the multimeter that we're getting a reading of about 147.2 ohms. Well, this resistor, this device, is rated at 150 ohms. So it's not reading exactly, but we are able to get the right idea. For a different resistor, for example, a 1000 ohm resistor, you can see that by putting it between the two probes, you get 1.036 k ohms or kiloohms. So it's reading 1000 or 1036 ohms. So, not exactly perfect, but it does get us in the ballpark. So when you're measuring the resistance of any device, you want to make sure you are measuring it directly with this meter. This is designed to provide a certain resistance, but as you can see, the meter isn't reading it as exactly that. Well, check this out. You can see that the only difference between the two resistors seems to be their color bands. Well, the bands provide a key. Now, the key represents different colors being different values. So we read the difference between the materials, or the resistors, using the color-coded keys. That key can be found in any textbook. Now, we're not going to worry so much about the key right now, because the point is to determine exactly what the resistance is, we're going to use our multimeter. But to learn it with using the key is also a value, and a key could be found in any physics textbook over near resistors. Now, I want to really focus on the fact that these resistors are a device that one is rated at 150, and this one right here is rated at 1,000 ohms. So we're talking 8.5, 9 times more resistance is provided by this resistor than this one. Yet they're the same size. Well, that has to do with the material that's inside and the resistivity. So, they're both being at room temperature. It's the material that it's constructed of that produces these different resistances. Now, as we look at two resistors in series, you can see that to hook them in series would literally be to touch them side to side so that both ends are touching. In this way, you can see that the current that flows in this side must go through this resistor, through the wires, and through this resistor to get to the other end. Now, according to our mathematical expression here, if I was to look at two resistors in series, I would have 150 ohms plus 150 ohms. Well, 150 ohms plus 150 gives us a value of 300 ohms when hooked in series. Let's see if that gives us that value on the multimeter. Now, when the multimeter is set to measure resistance or ohms, we call it an ohm meter because that's its function at this point. So we can see that we've got 147 ohms and 147 ohms. So if we add those two together, you should get 147 times 2, which would be 294 ohms. So if we touch these two together, you can see that we end up right close to 294 ohms. So in series, this is how you utilize the device called a multimeter when measuring resistances. And in series, this means that the resistors, the current that passes through one must pass through the other one. Well, to look and consider these resistors in parallel, you know that they're both 147 ohms. To consider the equivalent resistance in parallel, we're looking at 1 over 150 ohms plus 1 over 150 ohms. And that being equivalent to the inverse of our equivalent resistance. Well, if you carry out the arithmetic, you can see that the equivalent ohms, or equivalent resistance, of two resistors in parallel is actually 75 ohms. And that is an arithmetic value if you actually solve for them. Now, if we do hold these in parallel, putting them side by side, it means their two ends are touching each other, and these two ends are touching each other. So if we do that, we have 147 plus 147. Now, I used the 150. Shame on me. If you used 150, you'd get 75. If you used 147, you end up with basically 74 ohms after taking the inverse. So you can see that the relationships do play out. Now, the mathematics has never been an issue. We've always put a great amount of faith in our mathematics and our understanding. But as we get closer and closer to working with circuits, I wanted to introduce you to this device as a resistor and this tool as a multimeter. All right, well, when we talk about problem solving, again, we refer back to the problem solving technique used to address capacitors in series and in parallel. So let's take that same problem solving technique, that same train of thought, and apply it here for resistors.